So this is our lab mini project for 128. We chose to do a smart fan, and our implementation has two modes, an automatic and manual mode, which are set by buttons that a user can interface with. And then we have temperature readings given through UART onto a phone, and through SPI we have an LCD screen that shows off the mode and the speed that's set at. Then we have an Arduino that sets up an interrupt through PWM, and then we also have a PWM implementation to control the fan.
All right, so right now, as you can see, the system is in manual mode. So if we press these buttons right here, which are programmed by the init GPIO component on the processor expert. So if we click that, the speed should go up like this. And if you click this button, it should go down.
As you can see, the fan's also reacting accordingly.
Yes, and we have an oscilloscope hooked up to the output. So if I increase the speed, you can see that the duty cycle increases until it's at 100%. If I decrease it, it acts accordingly until 0. And then we can go to automatic mode, which is 1. And it'll react based off of the temperature sensor in the board. So we're going to use a hairdryer to heat up the board, and the fan speed should increase accordingly. So as you can see, the fan is now at max speed.
And you can see on Bluetooth that we have the temperature reading.
Yes, so now the fan will cool down the temperature sensor in the board, and the speed should start decreasing, and it is. It'll take a little bit to get down to where it was before.
Main problems that we had for this was using the processor expert. As we only had one lab with it, it was difficult to implement interrupts and other implementations such as PWM from our last labs, as we can use the code from those previous labs. So we had to start off essentially from scratch. Other difficulties were getting some of the modules that we added. So the Bluetooth and the LCD screen were a bit difficult to implement. The Bluetooth module, we had to use special processor expert module and then set that up using UART. And some additional difficulties was getting the fan to run at its max speed. I had to use a buck converter to convert from 5 volts to 12 volts, and motor controller to make sure the PWM was being transferred correctly.
And some improvements that we may have for the system were to add an LED that shows the temperature that the fan or that the temperature sensor is at right now. So we could have it so that yellow would be like warm, and then green would be cool, and red would be like hot. Any other improvements?
Besides that other improvement that we would probably want to make was to get rid of the Arduino altogether, to implement all of this on the K64, so we can only use one board, and probably 3D print the housing for everything, since right now it's spread across 3 breadboards and it's quite wieldy.
Yeah.